Okay, let's talk about multi-step calculations. So, multi-step calcs with sig figs. Alright, so let's say we have a problem such as this. 45.36 plus 2.3 times 10 to the negative third. And then we're going to divide all that by, let's say, 286 minus 84.1. Okay, so here we have addition, we have subtraction, and we have some division as well. So step number one is kind of follow PEMDAS, but we also have to remember that when you multiply or divide, we look at sig figs. But when you add or subtract, then we're looking at precision. In other words, do we know the number to the tens place, the hundredths place, the hundredths place, etc. So let's start with this calculation right here. I'm going to break it down into two steps. I'll start with the first part, and then we'll do the second part. So the first part is, bring it all the way down here, 45.36 plus 2.3 times 10 to the negative third. Now we should automatically see this number in scientific notation, so we ought to take it out anytime we're going to add, because we need to do it, we need to look at precision. So this number is actually equivalent to this number right here, times 10 to the negative third. So we'd move the decimal 1, 2, 3 times, and we'd fill in each of the little holes with zeros. Okay, so we've got 45.36, to which we're going to add a 0.0023. And when you do that, you get a 3, a 2, 6, 3.54. And all that's dandy and good, but remember that we can only look at precision. So we go from left to right and ask, which number do we know the least about precision-wise? So here we know everything in the tens place. This is an assumed 0. We know everything in the ones place. We know everything in the tenths place. We know everything in the hundredths place. But when we get over here, we have no idea what these two numbers are. So we only know here. So we know to the hundredths place. So our answer technically should be just to the hundredths place. However, we're not done, so we're going to use it for another problem. So we like to keep all this additional information because it's still important. It's our best guess and it's our best information that we have. We shouldn't round it off because that reduces the actual number. Okay, so now we'll do the next part right here. Bring it all the way down. And here's just 286 minus 84.1. We know the tens, or we know the hundreds, the tens, the ones, and the tenths we do not know because we have no idea what this number is here. So our answer should only go to the ones place. When we calculate this, we get 201.9, and again we only know here. We only know the 2, the 0, and the 1, and the 9 is just our best guess. Now we can go back to the original problem. Remember, we were taking this number divided by this number. So let's go ahead and do that. We have 45.3623, but we should keep in mind that we only know to the tens place in this one. Now we'll divide that number by 201.9, keeping in mind we only know to the ones place. In other words, only 4 of these numbers are significant, and 3 of these are significant. So therefore, when we divide them, we get an answer of 2.24677 times 10 to the negative 1. But we have to keep in mind that we only know here was 4, here was 3. Our answer should only contain 3 because our answer can only be as accurate as the least accurate number, which was this one. And now we have to ask if this number is 5 or greater. It is, so we round up. If we hadn't carried this additional information, we wouldn't have gotten the same answer. So it's really important that we carry these additional numbers, this 2, 3, and this 9. So our overall answer is 2.25 times 10 to the negative 1. So we have to pay attention to sig figs every time we add. We have to pay attention to precision every time we add and sig figs every time we divide. Let's move on to a different example.